Welcome to a fantastic Friday, everybody. Thank you for showing up for your learning one more time. Now we're going to go through a rapid-fire series of questions that are the same question type with different question numbers than the ones that you have before you. So as you come in, you go ahead and you grab the assignment there. Oh, no, I missed that one. And let's take a look at these question types. So if we had a situation where every day you've resolved for your New Year's resolution to read every day, and you're going to start with a small number of minutes. You're going to read for 8 minutes on the first day, and then every day you're going to read for 5 more minutes. One day you find that you're reading for 78 minutes, and you're wondering, well, how many days have I been doing this? How many days have I been reading and adding 5 minutes per day? Okay, and how many total minutes have I read? So let's take a look at how we can answer these types of questions. If we wanted to do this, what we're going to do, this is from the old number. So first thing that we're going to do is find a general term, right? And the general term for this, because we're reading for 5 more minutes per day, the amount extra that we're reading never changes. The first day we read 8, the next day we read 13, the next day we read 18, the next day we read 23, and so on until one day we're reading for 78. Okay, so we need to know how many days have we done this. So we create a general term, which would be, for this sequence, would be the first term here, 8, plus n minus 1, multiplied by the common difference, which is 5. And now I know that on one day it was 78, so I'm going to put that in over here. 78 is equal to 8 plus n minus 1 times 5. And so this is here, do the bedmas. So 8 plus 5n minus 5. And then here I'm going to subtract 3 from both sides, because I see that 8 minus 5 is 3. So I'm going to subtract 3 and subtract 3. And then that gives me a new line of 75 equals 5n. And dividing by 5 gives me 15. N equals 15. Okay, so now I know that I've been doing this for 15 days. I have been reading for 15 days. Great. So how many total minutes did I read? So now what I need to do is add up 8 plus 13 plus 18 plus 23 plus blah, 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 all the way to add up to 78. Adding all those individually is tiresome, so I use the formula for adding together an arithmetic series. So the formula there is S, the series with n terms, is equal to n divided by 2 multiplied by 2 times the first term plus n minus 1 times d. Okay, now evaluate that. So for S is 15. So my n is 15, so it's 15 over 2, multiplied by 2 times the first term. The first term was 8, so that's 2 times 8, plus 15 minus 1. I'm just going to write down 14 if you don't mind. Multiplied by the common difference of 5. Okay, and now I could factor this 2 in and take it out, but I'm just going to do the bedmas here. 16, so this is 15 over 2 still, multiplied by 16, plus 14 times 5. 14 times 5 is 70. So this is 86 in here. 86 divided by 2 is 43. So this will simplify to 15 times 43. And then once I do that, 15 times 43 is 430 plus 215. So that is 645.
Could you just scroll to the top one quickly? I just didn't see the map.
Yeah, I'm trying. And it's not responding to my touch. There. So for this one, I like to write out just a few terms of the sequence or the series, and make sure I can see it. Then I write out my general term here.
Did you need to subtract 5? Or
where? Oh, here, minus 3? Oh, 8 minus 5 is 3.
Oh,
so I just want to subtract 3. I thought I would skip a line. Yeah. I can see into the future. In the future, I'm going to be adding 3 to 5n. And I don't want to add 3 to 5n. I just want to know n. So I just subtract 3. And so then here, this is 645. Therefore, I've read for 645 minutes over the last 15 days. Interestingly enough, if I wanted to calculate the average number of minutes that I've been reading per day, it would be 23 minutes because 645 is divisible by 15. That's kind of cool. So it's not a weird, funky decimal. It's exactly 23 minutes of average reading time. And there it is right in the middle there. That's the middle term. How is that true? How is that possible? Anyway, I'll have to come back to that and see. Might be wrong. Anyway, yeah, 43 minutes. 43 minutes. That's correct. Okay. Now let's take a look at this one here. If someone has an income that's increasing by a certain amount every year, but it's increasing as makes 5% more money every year. Okay. So in year one, she makes this. In year two, she makes that. And then in the last year of her career, she makes this. Okay. I could show a few more years there. But in any case, if I want to create a general term for her income that shows the money that she earns in year N, I want to recognize that because this is increasing by a percentage, and it's increasing then by multiplication, not by addition, that we have here a geometric, oh, that's very kind, thank you, a geometric series. So my first term here, A, would be $44,000. My R would be 1.05 because that's increasing by 5%, so 1.05. And my general term here, P of n, would be 44,000 multiplied by 1.05 raised to the power n minus 1. Reason we want n minus 1 is the first term is this, so I want to raise this to the 0, so I have n minus 1 there. Okay. Now, that's my general term. If I want to know how many years did she work, well, I've got some bedmas to do here. I have this is the money she makes in the final year of her career. So I know that 75, 255 is equal to, 44,000 multiplied by 1.05 raised to the power n minus 1. Okay. I don't know n. Where did I get 5% from? Oh, I wrote it down there because I forgot to write it down. But if I look at it here, the reason why I need to specify that is because here, if you look, this is how much she makes in year 2. This is how much she makes in year 1. I should really show you another term so that you can establish that it's a geometric instead of an arithmetic sequence or an arithmetic series. If I divide here, okay, if I divide that, it will show me.
And for R, you just do like 1 plus the decimal percent?
Yeah. 46,200 divide by 44,000 equals 1.05. So that's growing by 5%. So as I was saying, I could have shown you in the third year she makes this much times 1.05. And then it would have been enough to establish that's growing geometrically, that's not growing arithmetically. Okay. In the example that I gave you, I think I did give you a few terms like that. In this one, I'm just showing you some examples, so I guess I got a little lazy. So, get a little lazy. Okay, so now I want to solve this for n. I'm solving for an exponent. That's tricky, I know, but let's go ahead and do it. So, first thing I'm going to do is divide away those big numbers. That's the first layer of defense that I will remove. And that will show me how much total growth has happened between year 1 and year n. So let's see it. If I have here clear, and I go 75, 255, divide by 44,000, and that equals, well, right now she's making 71% more money, 1.71, than she did in the last year. She's almost doubled her income. So I'm going to write that down. 1.71 equals 1.05 raised to some power, n minus 1. This is a task, so you're tasked with finding the answer in some way. You could use guess and check, or you could use writing these as a common base, but I don't know how to do that with these numbers. Or you could use Desmos. So this is me using guess and check. So I have this number, all right? So I'm going to say, okay, that's fine. Let's take one. Oops, let me move the calculator out of the way. 1.05. And I'm going to raise that to some power. I don't know what it is. Don't worry about n minus 1 right now. Just find out what power I need to raise 1.52 to get that. Okay? Let's try, I don't know, what do people want to try? Multiply that how many times to get that? Do people want to try 5, 10, 15, 20, 25, 30? What do you want? 5? Let's try 5. Okay? So you might create a table here, and you would say 1.05 to the x, and then what's the x? So we're going to try x is 5 here. So let's try that. And this is a 5-year career. That's a reasonable number of years to do a short career for. Raised to the power 5 equals, 1.276. So 1.28. Is that too big or too small? Too big or too small? It's too small. Yeah, because we want 1.7. So we got 1.2. So what should we try next? Should we try 6 or should we try 10? 10. Yeah, we need to go a lot bigger. So we go 1.05 raised to the power 10. Well, we're closer. We got 1.63. So what should we try next? 15 or 11? You said 12? Okay, let's try 12. There. 1.05 raised to the power 12 equals 1.79. Is that too big or too small? It's too big. So let's try 11. See how we're zeroing in on it? Clear. 1.05 raised to the power 11. 1.71. How's that look? Pretty much exactly it, right? So there we go. We found it. It's 11. So did she work at this career for 11 years?
11.99.
11.99. Yeah.
9959.
What's another word for 11.99599799959?
12.
12. Yeah, she worked there for 12 years. Why did we get 11 and it's 12? Oh, right. Because n minus 1 equals x. That's the exponent that we want up there, but n is the number of years that she worked, so we have to add 1 to that number we found, okay? Be careful, people. There's a funky exponent up there. 11. If I write this now as a common base, okay, I can do this now by virtue of guess and check. 1.05 raised to the power 11 is equal to 1.05 to the n minus 1. This is so that I can solve for n minus 1. So 11 equals n minus 1. 12 equals n. So she did this career for 12 years. And of course she did, because I love the number dozen. So that's why I did that. Okay, the number dozen. What was the total amount of money she earned over her career? Okay, so we have to add up all 12 years of her salary. Let's do that with a geometric series. So I'm going to write S of n is equal to a, the first term, multiplied by 1 minus r to the n, all divided by 1 minus r. All right. So we'll notice that this works out to A was the money that she earns in her first year, $44,000, multiplied by 1 minus 1.05 raised to the 12, because n is 12, all divided by 1 minus 1.05. Okay. This I can punch on my calculator. So let's go for it. Boop, 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 boop. Clear everything. 44000 multiplied by bracket 1 minus 1.05 raised to the power 12 divided by divided by bracket 1 minus 1.05 end bracket equals, she earned in 12 years a little over $700,000. Okay, so 700. I'm going to write down 703,500 4. 700,354.
Why, isn't the answer 11? Oh, no. Wait.
She earned $11 over her 12-year career.
No, just there. Oh.
What, there?
No. Well, yes, but.
N equals 12.
Okay, yeah, just over there.
Because in the first year, it's to the 0. Okay. So that's how much she earns over her career. What's the average amount of money earned per day? Per day, I meant to say per year. And yours, it's calories eaten per day, so that's still correct. Mine should be per year because, hey, I am just doing some examples. I didn't proofread this very well. So how do I find the average amount per year? Just divide it by the number of years.
Wait, so is it only 1.05 raised to the 12, or is it that whole bracket raised?
Where's your question?
Just
1.05 raised to the 12.
Not
It's just 1.05 raised to the 12.
okay, the one's not.
No, the 1 is not raised to the bracket. No. And so, yeah, just divide this by 12 to find the average amount of money earned per year. So let's do that. Divided by 12. Now yours, the number that you're hunting for, you'll find it's a little bigger than 12. I'll give you a hint. It's an even number of weeks. Okay, so there, 58. This is her average amount of money that she earned per year. So 58,363. So let's take a look at that and let's see if our answer looks reasonable. She started out earning 44 grand and she finished up earning 75 grand after 12 years. And then we found that the average amount of money earned was 58 grand. That's right in the middle there. That looks pretty good. I trust it. Kate, can you go to the bathroom? Yes, you may. So now this one, I just changed the interest rates. So it's very similar question here for you. If Harjeet has a grand and he wants to compare earning simple interest to interest compounded monthly, and he wants to use the money in 30 years, which option is better and by how much? So to answer a question like this, you compare simple interest with your compound interest. So use your formulas. Here, simple interest, the future value of your simple interest investment is going to be the money you put down in the beginning plus the interest. Another way of finding the interest on a simple investment is P times R times T. Okay? So here, future value is going to be equal to the principal, which is $1,000, plus 1,000 multiplied by the interest rate, R. So 15% simple interest. Wow, who's giving him that? I don't know. I made these numbers up. These are not to mimic reality. Times time. He's going to do this in 30 years. Okay? So that's my formula. It's very straightforward. Ha ha ha. It's straightforward because it makes a line. Ha ha ha. Okay. So let's do the math here. 0.15 times 30 would be 4.5. 4.5 times 1,000 would be 4,500. So he earns $4,500 in interest. So the total value at the end is 5,500. Ooh, there's a Fibonacci number in there. I didn't know I was going to do that, but there I did. Oops, I did it again. Compound interest now. That's how much he's going to have in the future. Okay? And if you need a calculator, there's no shame in that. All right, the future value of the compound interest here, well, that would be $100 multiplied by 1 plus I. Oh, wait, what's 1 plus I? Raised to the power n. Wait, what are I and n? Oh, yeah, I have little mini formulas for those. I is the interest per compound period, and there's 12 of those, so 12 is equal to C. There's 12 compounding periods per year, so I need to divide the interest by that. So interest is R divided by C. So in this case, it's 0.09 divided by 12 is equal to, well, that works out evenly, doesn't it? It's 3 over 4, so that's 0.0075. Okay, you can check that on a calculator if you want. 0.09, that's the 9% interest divided by the compounding periods. That still doesn't look like a 9, Mr. Jennings. There, now it looks like I had a lot of trouble drawing a 9. Okay, so that's my interest, and I'm talking, so I should probably check my work. Yeah, okay, it's right. All right. And then let's keep going. So that's I. And then N, is equal to time times the number of compounding periods. We got 30 years times 12 compounding periods per year, so that's 360, just like the degrees in a circle, 360 compounding periods. So I can substitute those values in. 1,000 multiplied by 1.0075 raised to the 360. This, ain't nobody wants to do mental math and do that. No, that would take you all day, and you'd make a mistake on like doing it to the 100th power, and then you would hate life. So just use your calculator. Calculators love doing this type of problem. Raise to the power 360. See, watch how happy this makes my calculator. See, look, that's a happy calculator. There, his money will grow by 14.7 times. So I'm just going to multiply that by how much money he put down in the beginning. And it gives me 14,730. Did I round that correctly? I don't care. All right. So which one is better? Oh, clearly the compounding monthly 9% interest is way better than 15% simple interest because we've got a decent amount of time for that compounding to catch up and pass it. Okay? So, great. Good news. And by how much? Well, by this amount of money, subtract how much he would have if he did simple interest. So there we go. So 9,230.57. Okay, so that's fine. So this would be how much better? So we did 14,730 minus this number here, color code it for viewing ease, 5500 is equal to this number here, 9231. 923. I'm just gonna say 30, and I'm gonna say that he donated the cents to charity. Okay, last one. If Sally and Abdullah are looking at, here is something that I forgot to add to your sheet. So you want to add this to your sheet. They are going to pay their mortgage down over the longest amount possible in Canada, 30 years. So add that little detail, otherwise you have a problem with two variables and you can't solve it. So make sure that on your sheet you add 30 years to your question number 4. Okay, so they can afford a maximum monthly mortgage payment of $3,000. Okay, if they can get a 2.1% interest rate compounded monthly, which they will pay down over 30 years, what's the maximum amount of mortgage they can afford to borrow towards a house? Okay, let's find that out. So this we need to know present value of an annuity. Present value of an annuity is given by this formula. It's given by the regular payment multiplied by 1 minus 1 plus I to the negative n. 1 minus bracket 1 plus I to the negative n, all divided by I. Okay, let's plug and chug. First, we need to get our I's and our N's and our R's. So here's our R, regular payment, $3,000. R, big R. Here is the little r, interest rate. And then R divided by C, again, we're compounding monthly. This is very common to be compounded monthly, so get used to dividing by 12. R divided by C, so 2.1 divided by 12. That gives me my I. And what is 2.1 divided by 12?
Wait, why is it divided by 12?
Because compound monthly. C is equal to 12. So this is the interest rate. 2.1% divided by 12 is I.
Like 2.1 per year?
Taking 2.1% interest rate per year.
Oh, okay.
Yeah, that's typical for this is a little low for a mortgage. This is where it was like a few years ago, actually. It was like low twos. Nowadays it's like high twos when I checked last night.
Okay.
So yeah, so the number you have there is 2.4. That's good. That's competitive. I think that might be quite good.
Have they been changing it to a decimal?
Yeah, I could change it to a decimal there, Mac. Yeah, I could do that. This is a 0.021, and try and erase this here. There we go. That's good. Yeah, I was going to change it later. That was actually in my head, like, oh, Mr. Jennings, you didn't change that to a decimal yet, and you will confuse them. Yeah, so thank you for pointing that out. So let's do that on calculator, because I could do it in my head, but then you have to watch me do mental math. Divided by 12 equals, here's I, 00175. 0.00175 is our monthly interest rate. It's about 0.2% per month, and that should make pretty much sense because it's about 2% per year, and there's about 10 months in a year, so that's good. So, and the time is t, is 30, but so n is 30 times 12. Oh, again, it's 360. Okay, 360 is our n because 30 times 12. Because we're going to multiply t times c. Okay, so now let's plug that in. We want to know what's the maximum mortgage they can afford. And so here we go. The present value that they can afford to borrow is equal to $3,000, their monthly payment, which they will make 360 times over the lifetime of their mortgage. So a lot of times. 1 plus I says 1.00175 raised to the power negative 360. And bracket, note this is raised to that power, this 1 minus is not, because that's what the formula says. All divided by 0.00175. And then I say, well, let's just plug and chug on decalculator. Clear everything. $3,000 multiplied by bracket 1 minus. Am I the only one that does Gregorian chant while they punch things on a calculator? Anyone else have that habit? Yeah, sorry. You develop weird habits when you're like trying to fill the air or fill the space while you're doing something that's otherwise less interesting. Divided by 0.00175. There. That looks like the size of a mortgage, doesn't it? Aiden?
Where'd you get the 360 from?
360? Oh, 30 years, right? So how many payments? What's their number of compounding periods? Yeah. So you have to find n, you take t, which is number of years, and multiply by the compounding periods per year. Because we're compounding monthly, that's 360. Okay? And so then we get a total mortgage amount of 800 grand. And nowadays, that gets you into the housing market. It's hard. It's hard to get into the housing market.
Ours is 2,000.
768 what?
Ours is 2,000. So I got 500.
Yeah, on your sheet, on my sheet is 3,000. I'm using different numbers so that you get to see me go through these questions. I'm not answering the questions for you. You do your questions. I do my questions.
Wait, but how did I get the same?
How'd you get the same percent? Well, then you did it wrong because your percent is 2.4. 2.4 divided by 12 is that's easier to do. That's what is that? 1.5? Wait, no. 0.2? 0.2. That's exactly 0.2. Yeah, 0.2% per month. Yes, there we go. So if they're making a 20% down payment, what's the most expensive house they can afford? All right, let's find out. How would I do that? I don't know what the most expensive house they can afford is, but I know that they're paying 20% down, so I know this is 80% of their house. And the down payment is 20%. Let's do it. Let's let A equal total price. Let's let D equal down payment. Both are unknowns right now. And so here's what we're going to get. Okay? There's 20% down payment. So D equals 0.2, that's 20%, times A. So now that takes this unknown and makes it only one unknown. Okay? And then I have this. A is the total price, and it's equal to the down payment plus the mortgage amount. That's this number here, the present value of the mortgage. Okay? Down payment plus the mortgage, right? Make sense? Yeah, sure. Okay, so let's see what that is. Let's sub in for A. A is the total price equals 0.2A plus 800, 768. I'm doing this the long way. I'm really not sure, but I'm just going to make some let statements and then put together formulas that I can understand and then manipulate them. So here I'm going to subtract 0.2a from both sides. So then I get 0.8a equals 800. 100,768. Okay. That's when I subtract 0.2a from both sides. Now I go ahead and redraw my numbers, which were ugly. There we go. Now I go ahead and divide both sides by 0.8. And this will give me the total amount that they can afford. Okay. This divided by 80%. Because that was 80% of the price, right? So if I divide that by 80%, it'll give me the whole price. Sophia?
Sorry, where did you get 0.8?
Oh, I subtracted 0.2a from both sides. And then a minus 0.2a gives me 0.8a. Let's write that in. That's good. Oh, and was that your question? So I subtract 0.2a from both sides.
But how do you get 0.8?
A minus 0.2a. That's like saying a minus 20% of a leaves me 80% of a. Yeah. Or $1 minus 20 cents gives me 80 cents. Because that's one apple minus a fifth of an apple leaves me 4/5 of an apple. So then I just punched that on my calculator. I've already got the number here. So now all the algebra does is it shows me, yes, it is correct, Mr. Jennings, to divide by 0.8, and that will find you the maximum value of a house that they can afford. This couple can afford a house that's just a hair north of $1 million. Just a hair north of $1 million they can afford. So there you go. This is how you answer all these question types. The last question I'm going to leave you on your own. I really want to see, if you were to scrape together all the money that you can imagine scraping together as a 16 or 17-year-old in our society, given your current situation, and then you decided, I'm going to just get disciplined and start putting that away right now towards my retirement, which will happen in 50 years when I'm 66 or 67, what would that money look like? Let's try and surprise yourself with some big number. And I said, what did I say? Work with 9%? Yeah, imagine that you can get 9% from the stock market. All right, so best of luck with all of these. Ask me any questions that you have. And see how well you can do.